So here's the conclusion to the combustion reaction. So we're going to go through and we're going to answer each of these questions. What happened when I first placed the match in front of the pipette? You remember, actually, nothing happened. Nothing happened. Well, why did nothing happen? Well, it didn't burn. Well, there's two reasons why nothing burned. And the first reason is that, if you remember, combustion reactions need oxygen. Well, where is all the oxygen? Well, if you remember, I had this pipette, and we had all of the gas on the inside, and there's no oxygen on the inside. It's all filled with the gas. Where the oxygen is on the outside here. So it's like the candle. The candle can't burn unless it has oxygen. So nothing happened. It needs oxygen in order to burn. So it needs oxygen, or I'll just simplify by saying O2. It needs O2 to burn. What happened when you place the match in front of the pipette and squeeze the bulb once? Okay, in this case, a flame was produced, and the flame went out, and then I don't know if you saw it, but also the flame went in. The flame went out. That's because I was squeezing it, and when I squeezed it, the gases from the inside combined with the oxygen on the outside and the flame, and it burned. It combusted those gases out. And then what happened is my reflex was to let go, and so I let go of the pipette, and what it did is it sucked the flame and the oxygen on the inside, and it burned the remainder of the gas on the inside. I was expecting it just to actually come out, but in this case, it went in. So the flame went out. Actually, the flame, we should probably say it moved out. The flame moved out. Then it got sucked in. What happened when you squeezed the bulb multiple times? Well, in this case, nothing happened. Well, why did nothing happen here? Well, what can you assume that if I'm squeezing it multiple times and nothing is happening? Possibly means that when I squeezed this the first time, the gases came out. When I let go, the flame was drawn in, and it combusted all the remaining gases that were to combust on the inside. What's on the inside of this now is carbon dioxide and water. So nothing happened. In this case, it's because all the gas was consumed, or all the gas, it combusted. There was none left. So we're just going to abbreviate. So there's no gas to burn left. Does the gas have an easy time combusting by itself? This is kind of referring to this one. Does it combust by itself? No, it needs oxygen from the air. So it needs O2 from the air in order to combust. Why is there a difference between trial number 1 and trial number 2? It's because the flame moved out, and because we had the oxygen that was present. So in this, in trial number 2, so in number 2, we have a gas that's flammable and O2 for a reaction to take place. So nothing happened in the first case because we need oxygen in addition to the flame. When I squeezed it, the gas came out combined with the oxygen. Now we have a nice mixture of the two, and that's when we have the reaction. if we squeeze the bowl multiple times, all the gas that was flammable was used up. So these are the two chemical reactions that we have taking place. So this is going to give us extra chance at balancing these things as well. So we are starting off with calcium carbide. We can leave a space for a coefficient. Calcium carbide is CaC2. And this was then placed in the water, H2O. This produces a compound called calcium hydroxide, CaOH2, and I'll explain what this means over here. And it also creates this compound C2H2. This is what is flammable, and this is called ethylene or ethene gas. So how many calciums do I have over here? I have one calcium. How many calciums do I have over here? I have one. How many carbons do I have? I have 2, and here I have 2. Now this means I have 2 OHs. This is a confusing symbol that you'll learn about in chemistry. I have 2 O's here and I have 2 H's. So I have 2 OHs, so 2 O's and 2 H's. So how many O's do I have? I have 2. How many do I have over here? I only have 1. So I'm going to have 2 times my 1 gives me my 2. This will also give me how many hydrogens? 2 times 2 gives me 4. Let's see how many hydrogens I have on the right-hand side. I have 2 times 1 for 2, 2 times 1 for 2, and 2 plus 2 is 4. In that case, it is balanced. So this is the substance that's actually going to be burning up. Again, it's called ethylene gas. And let's go ahead and we'll start with this C2H2. And sometimes these combustion reactions are hard to balance. But if you remember, anything that's combusting requires oxygen. And our end products for combustion reaction are going to be carbon dioxide and water, H2O. So this may take a little bit of going back and forth because if you remember, we have oxygen over here, but we have oxygen in the 2 compounds. So here I have 2 carbons, here I have 1 carbon. So I'm going to need to put a 2 right there. This gives me 2 oxygens, but then it gives me 2 times 2, which is 4. Now if I look at the oxygen over here, I have 1 oxygen from the water. So I have 2 times 2 plus 1. That gives me 5 oxygens on the right-hand side. But remember, these are in 2 different compounds. So I am trying to get to an even number. I have 2 times 2, which is 4, and I have plus the 1 is 5. My next even number is going to be 6. So if I put a 2 right here, this gives me 2 times 1, which is 2, plus the 2 times 2, which is 4. 4 plus 2 gives me 6. So I have 6 oxygens on the right-hand side. Okay, so how many am I going to need on the left-hand side? Well, I'm going to need to have 3 over here. Let's see if everything's balanced. I have 2 C's, and I have 2 C's. I have 2 times 2, which gives me 4. Plus, I also have the 2 times 1 for 2. That gives me 6. So the oxygens are balanced, but now my hydrogens are not balanced. I have 2 times 2, which is 4, which means that I'm going to have 2 of these. Well, let's start this process over again. 2 times 2 is now 4, so I'm going to have what number to replace the 2? I'm going to have to change that and make it into a 4. So now I have 4 carbons to match my 2 times 2, which is 4. And for the oxygens, I have 4 times 2, which gives me 8. Then I have 2 times 1, which gives me 2. So I have 8 plus 2 gives me 10. What number actually needs to replace this 3 is going to be a 5. And they should all be balanced now. So double check, 2 times 2 is 4, 4 carbons. Hydrogens, 2 times 2 is 4, 2 times 2 is 4. And for the oxygens, I have 10, and I have 8, and 2 is 10. It's now balanced. So the summary of this lab is that combustion reactions require oxygen. And this also just gives us a little bit of practice to balance equations. But if you don't have the oxygen present, you're not going to burn it. And then after the reaction, this is what we end up with. We end up with carbon dioxide and water. There's nothing left on the inside of this except for the carbon dioxide and water, which is why nothing happened when trying to squeeze this multiple times, because the gas was all consumed or the gas all combusted in the combustion reaction.